Today's title, Advanced 3D Modeling and Rendering, second class, okay? So we will have midterm exam today. Next week and next after next week, we will review your project progress, okay? So you need to report one by one or team by team for reporting your final project progress. And your lab exercises supposed to be finished and submitted until next Monday, okay? Until next Monday, all gathered your missing or some unsubmitted lab exercises will be collected and will be applied to the final scoring, okay? Quickly review what to do today. Theoretical background of CAD and graphics as the second class of advanced modeling, geometric modeling, and visualization, rendering issues. So I told you the term modeling in this semester is geometric modeling, but actually information modeling, specifically for building, that is BIM, building information modeling, is one of the topics of next semester in digital design class. But this semester we have learned about mostly geometric modeling and its visualization. So still our focus is on geometric modeling. So we mostly deal with geometric modeling. But let's quickly review. When you get here as a freshman, we actually reviewed something about computer graphics, geometric modeling, geometry and topology, and so on. But today we will review again, and then probably and hopefully you recognize some fundamental theories and background and what you have done using 3D Max, editable poly, or some geometric editing. Some tasks you have done by using that kind of 3D software they are all some theoretical basis are already well defined and well made by someone. So the most important part we will take a look at today again. And some few lab exercises, okay. First lab exercise, one way of smart CAD, smart computer graphics system using Autodesk Homestyler.com. Two versions, PC version and mobile version. We're gonna review that one as a lab exercise number one. And number two, something about geometric modeling using 3D Max. And number three is about some mental way, visualization, technical aspects, something advanced one, using some texture map and so on. They are the topic today. Let's briefly talk about some conceptual issues about high level versus low level and high LOD versus low LOD concept. The term LOD here means level of detail or level of development. So what is the comparison between high level and low level? Here I briefly listed up. The term high level usually covers the concept of introductory things, outline, general, and fundamental theory background, okay? High level. If you see something in higher level, you may see something entire aspects, not the detail. Forest, not the tree, okay? But to the contrary, in lower level, you can see something detailed, but it's not easy to see entire aspects, entire features. But anyway, something particulars and something specific theory. In other words, some fine-grained, detailed objects, things. In general, we say it in low level, okay? So in terms of our class topics, we can divide our topics in higher level and lower level. So this is the the highest level and the lowest level things. Let's take a look at developing the capability of design computing. Very rough and something coarse detail description. Enhancing digital communication skills. Usually our communication in design domain, architecture domain, engineers or construction domain, we usually use some standardized symbols, draftings, drawings. But now you have learned some 3D, photorealistic rendering, wireframe, line drawing, and so on. Something digitally augmented objects to communicate with other designers or anyone others in your project. And also practicing digital design presentation using lots of applications. Learning interoperable operations between heterogeneous applications. Heterogeneous applications here means totally different software, such as AutoCAD, 3D Max, SketchUp, PowerPoint, even MS Word, whatever. You can copy and paste simply, or save DWG or SketchUp file and import it into some totally different application, okay? Exercising Photoshop and related 2D visualization tools, and some specific things. Training specific commands, training specific buttons, icons in AutoCAD, SketchUp, 3D Max. They are something about details, so-called lower level, okay? So comparison between high level, lower level, very straightforward. Anyway, we need to stick to some high level issues, but in reality, in lab exercises or your final project, you have to know detailed level. Amount of detail issues there are, we have to focus on what you need, what you have to do. If you understand, if you comprehend high level issues properly, and then some lower level detail technical aspects, you can find out by yourself, simply by using Google or some additional references, okay? High LOD and low LOD, this is just one metaphor for describing the comparison between two different things. High level of detail simply has amount of more polygons, very well defined and some complicated geometry. Contrary to that, lower level or low level of detail shows fewer number of polygons. And simple comparison between those two things, okay? High LOD and low LOD. Probably you can find out what the meaning of the term level of detail. And high LOD, low LOD, okay? So sometimes you stick to this kind of lower level of LOD sometimes, but sometimes you have to very highly developed level of detail you need, okay? It's up to your situation, up to your decision, okay? Let's quickly review some theoretical background issues about 3D modeling and design representation. I showed you this one lots of times in terms of CAD history when we believed 2D drawings are design itself, 2D drafting by using AutoCAD or some plotters, 2D printers. At that time, that was enough for designing. But in this semester, we have learned this level, this stage, okay? Second stage, surface-based 3D modeling. By using this kind of 3D model, we can easily generate front view, top view, so-called floor plans, elevations, sections by using this 3D computational model, one original source model. But what's next? I told you briefly last week, solid modeling, parametric modeling, information modeling. Our subject is building, not geometry, okay? We are not dealing with polygons, lines, points, numbers, and so on. we are dealing with some design elements for building, in a building. So that's building information modeling, BIM, okay? But those three advanced features, issues, we're gonna deal with this one next semester in digital design class. But anyway, we need to know one by one, but not details about this area. You should know some geometric modeling, especially surface-based model, and you should differentiate at least just simple surface-based model and the solid model. This is surface-based model. By using 3D Max, there is some FFD edit to modify your simple surface plane like this one, okay? Or some knobs-based curve generation. We can control some additional control vertices, okay? There are a couple of amount of different ways to edit this kind of thing. Surface-based model, the surface of this one is mathematical, theoretical. I told you, this is not real. In our real world, in your daily life, there is no this kind of surface. Everything you have has its thickness, okay? But in surface-based model, the thickness is 0, no thickness, because this is surface, okay, plane. But one good thing, very good thing, and that why we need to use this kind of thing is simply its capability of visualization. You can visualize anything easily, quickly, and comparatively lightweight way, okay? It's not heavy. So surface-based model is broadly used in actual industry, especially game design, character design, product design, and so on. But the problem is we are dealing with some real objects in real world. You are designing ultimately some design objects, chairs, desk, furniture, walls, or some interior finishes, or building mass, window system, doors, and so on. They are all building elements, design components, not surface, point, lines, patterns, okay? Anyway, that's why we need to deal with solid models, which has thickness, something solid fill inside. So in terms of mathematical definition, theoretically, Requicha defined simply in this way. Solid model is an unambiguous computer representation of a physical solid object. We are dealing with a physical solid object, okay? Anything you experienced in real world are physical solid object. You are not designing some game items or game characters or game environment. Game environment is totally virtual, cyberspace. You don't need to take care of its thickness or something inside of that material. But our subject all are in real world, physical solid object. So without ambiguity is one important aspect. So here I list up some looking solid model, 3D model, but non-solid 3D model. Take a look at this one. 1, 2, 3. 3 planes, they are all 0 thickness. Mathematically defined plane. This one doesn't have any thickness in terms of computer graphics representation. This is not real object. How about this one? This one looks solid, but take a look at this dangled surface. You can easily generate this kind of object by using 3D Max, especially SketchUp. Amount of surfaces, connections. But because of this one, this is non-solid. How about this one? This is parametrically defined object. There is a single line, and its radius 0, and specific radius here. So we can generate this kind of parametric 3D object. But the problem is this area. There is a string which has zero thickness. In other words, just a line, curved line. In real world, no such object. Okay. How about this sharp area? It's not easy to make this kind of really sharp component. Anyway, another one is Klein's bottle. This one is an example of, simply say, 3D version of Möbius string. Okay. If you follow the surface of this bottle, there is no inside or outside. It's not solid object in terms of surface connection because of this ill-defined connection. This is just surface. There is no inside or outside. In other words, 3D version of Möbius string. Okay. Another example, why we need solid model. I told you, without ambiguity. That's one way of solid representation. You know, this is kind of illusion. It's invalid, okay? We can easily recognize that is invalid. But how about this? This one is looking like 3D object in wireframe view. But the problem is, you may think about this one supposed to be this object in 3D, but actually, how about this one? Actually, those two things can be represented in this wireframe, totally same. Okay, that's the problem in this kind of ambiguous definition. If this is solid, non-solid, I mean the combination of surface object, there is this kind of ambiguity. Okay, all these are totally same, one single representation, this one. In other words, it's ambiguous. So when we define by using computers 3D object, which part is solid, which part is void, that is another important thing for computers to design physical real-world products without any ambiguity. That's the issue. So let's For doing that, for handling that kind of background issues, let's quickly review geometry and topology again. Simple rectangle shape on your computer screen. To the computer, how to define this one? How to recognize this one as a rectangle shape? Theoretically and mathematically, it's simple. Firstly, computer should understand there are 4 points, which has Cartesian coordinate system, right? Totally mathematical, very simple. 2D, X, Y plane, there are 4 points, and computers must have this connection, 4 connection, so-called lines, okay? And the computer at the end, it's supposed to be understanding those connected 4 lines gonna be one surface, and then eventually simply draw on your computer screen without any problem. Okay, this is geometry, which has x, y coordinate points. How about topology? What is topology? Geometry mostly deals with this kind of Cartesian coordinate points, location. Topology defines their relationship, okay? So take a look at this one. By using 4 different vertices and their relationship for edge 1 is the connection between vertex 0 and vertex 1. That is edge 1. And one single face gonna be composed of this kind of series of connections, okay? Series of edges. So for clear comparison between those two things, the different geometric shapes with the same topology, let's take a look at this one. This one has this kind of connection. Another one, take a look at the connection, the relationship, totally same. In other words, in terms of topology, those two things are exactly same, but their point vertex location is different. Different geometry, okay? So this kind of difference you can find out easily, even if it has same topology. How about this one? Same geometry. In other words, actually not same geometry, but let's assume that exactly same location of the point. But because of different topological definition, they are looking different. This one is looking like cross, and this one is rectangle shape. So for computers, both geometry and topology are necessary, okay? When we see human beings cognitively recognize this shape without any this kind of additional information, we can recognize that in our human brain. But to computers, very explicit and very mathematical, theoretical, okay? So why we have to define this kind of relationship as well as Cartesian coordinate system? Simply because computer is not that smart compared to human being. So that is why we have geometry and topology concept. Actually, not only for computers. This one for theories in mathematics or some other applications in real world. Space, surface, line, point, they are all about geometry, the terminology in geometry. Shell, face, edge, vertex, that's topological definition, terminology, okay? So when we are dealing with some 3D Max or SketchUp or any other type of 3D surface-based modelers, we have to deal with one of these components. They are geometric subcomponents, topological subcomponents. In real world, in real application, there is no differentiation. We use all together. Anyway, by using those definitions, we can extrude them to create specific 3D object. But if you draw this one enclosed rectangle shape, and then you can create this kind of 3D object without any problem. Something looking like a real world object, even if it's surface-based model, even if inside is totally hollow. Anyway, in terms of visualization, in terms of visual effect, you can make it real world 3D object. But if you have this kind of unclosed one or some topologically ill-defined one, dangled elements, dangled object, because of them, they are looking something wrong in real world, physical object. So this is physical object looking, others something ill-defined. In solid modelers, there is no way to define this one. But if you put some thickness here, some thickness, even if it's 0.1 millimeter, in solid modelers, you can design it, you can model it, okay? But you cannot in zero thickness surface in solid modeling tools, such as Revit or some others. So that is one example of advanced computer graphics tool. So here I list up some enclosed, closed loop, and unclosed loop. Only this one generates something valid solid object, okay? But in solid modelers, in other words, SketchUp or 3D Max, you can define anything because it allows lines and zero thickness surfaces, polygons. So let's quickly compare geometric modeling, which we have been dealing with in this semester for CAD and computer graphics course, versus information modeling, okay? Especially information modeling for buildings, so-called building information modeling. Okay. In terms of history, one single page diagram, geometric modeling is a subset of information modeling. Okay. In that diagram that I showed you before, totally contains 2D drafting contained by surface-based 3D. Surface-based 3D modeling, totally one part of solid modeling. Solid modeling also part of parametric modeling. Parametric modeling is one subset of information modeling, building information modeling. From 2D drafting to 3D modeling, and what's next? That was the topic of last week. And here, 2D drafting, 3D modeling. Usually we can simply say there was 2D, or there is still 2D and 3D, but actually 3D surface model, 3D solid model, they are totally different, even in 3D modeling issues, and some more issues. That is building information modeling, simply information modeling, okay? This one is really good for visualizing something by using computers. That's one way. This is the history diagram that I show you. I told you this is the largest one. This one contains this one, also contains in this direction, okay? This one is subset of this 3D surface-based model. That is why if you design your object by SketchUp or 3D Max, you can easily generate 2D section, 2D elevation, floor plans by using some orthogonal view, not perspective view, okay? They are all standardized views. Actually, last year when you were freshmen, I introduced you this one. At the time, there is this kind of application app, but now you can take a look at this one in terms of that comparison between geometric modeling and information modeling, object-based modeling, homestyler.com. This is web browser version of Homestyler. In this Homestyler, after logging in this website, you can find out there is some design editing mode. And if you design your plan, your walls, and some furniture, you may find out there is no way to define polygons or some surfaces or lines and so on. You have to design object-based. In other words, there is a column, there is U-shaped wall, curved walls, L-shaped walls, and so on. There is no surface, no polygon, no point, okay? So this one is looking lightweight and web version of the simple application, but actually this is, in terms of CAD history, this one is much advanced one compared to 3D Max or some others, okay? Even if it has some limited function or something else, if you click this one, you may find out wall information. You can control wall thickness, length, location, and so on, object base. So this is web version of homestyler.com. Even if you are designing in 2D plan mode, if you load this wall and objects, they are all in 3D, okay? Simply you can take a look at 3D view like this. Another one, you can easily save the file, AutoCAD file, which has layers like this one. Also, you can export this model into Revit model. In Revit, you can visualize it again in building component-based. No geometry. Actually, geometry information is one part of this one, but anyway, you can click the walls and the bed, some door objects, and you can update its information, edit it. This is the mobile version of the homestyler.com. You can load an empty room and you can put some your own design, decoration, some products. If you choose this product, you can load that one and edit it, okay? Also, you can take picture like this and change and update something like this one. Let me quickly show you some demonstration. Homestyler.com. This is PC version of homestyler.com. In the lab exercise, number 1 is to deal with this homestyler.com edit. Okay, this is PC version of homestyler.com, and if you can log on by using Google, Facebook, and your own email account. Let me log in using my email address, my account in Autodesk, and click Create New Design, and then you can load this kind of editor. Okay, this is the editor mode, and change unit to meters. And let me quickly load L-shaped room. Okay, I just load L-shaped room, and if you click one of the walls and click information, you can change thickness from 100 millimeter to something else. Or you can easily change its location. What if you click different category, living room and sofas, as you experienced before? I can load this sofa like this one, okay? Simply drag and drop here. And living room accent tables. Okay, it's not loaded because of some traffic. Anyway, this is 2D view, but if you click this one and click information, you may find out this one is new modern sofa, which has specific related information. And if you click 3D view, you may find out this is not simple 2D image. This is 3D image. And you can take snapshot by using 3D render scenes. Okay. Actually, we're going to deal with this one in lab exercise hours, but let me quickly show you some example. How about this one? This is Autodesk Homestyler generated render scene by using same one, mental ray. Mental ray is based rendering, but not your CPU, not your computer. Rendered by cloud computing. And also, I would like to show you another demo of this one, web version. Mobile version of the homestyler.com, okay? Okay, this is my smartphone, and there is Lori, my daughter, homestyler.com. Okay, if you can simply install your homestyler.com in iPhone or any type of Android phone. Autodesk supports your installation without any platforms, different platforms. Anyway, by using this one, if you click Create New Design, you can take picture, but let me load an empty room. You can navigate some empty rooms. What if this one? Click one of the rooms and redesign, and then you can load this design. Okay, because of some traffic probably it takes time for loading. Okay, let me change the Wi-Fi. Okay, just loaded. Okay. Okay, let me add one of these component. Okay, this one. Add to design. And there is the chair, but the problem is this one is too small compared to this area. So let me load living room sittings, sofas. Let me load something bigger one, like this, black. Add to design. Okay, there is a couch. You can rotate. Okay, I don't know why this one is looking. Okay. Okay. Or you can simply change the color, paint, or wallpaper. Click the color, and if you draw somewhere here, and then entire part auto-selected and change the color like this way. Okay, auto detection. Let me close this one. Not save the design. Create a new design. At this time, let me take a picture. Okay. I can take the picture here like this. You can take picture like this one by using your camera in your smartphone or smart device. And this one auto-generate, auto-detect where is the wall and where is the floor area, like this way. Take a look at this one. So this one auto-generate the ceiling line and the bottom line, but you can adjust the height and location, width, and so on. Anyway, simply reuse this one, and you can put the height. At this time, let me use just default 2 meter height and click OK. And then you can load your object. How about this one? Add to the model. And this chair gonna be added and placed like this one, this way. Okay? How about people, human? Add to design. And you can place this human here and rotate. Okay? Because of some ill-defined height, I intentionally use default, so that's some problem. But anyway, living room table, coffee table, this one can be added to the design like this way. Okay? If you bring this one closer to you, this one gonna be bigger because of the perspective angle, and rotate and delete, whatever. And how about the wall paint? The same color to this area, just simply drag, and then auto detection. but because of traffic, probably it's still loading. But anyway, that area auto-detected and filled with that color. This is some simple 2D image-based regeneration. But anyway, this is one way of using this design. You can click this information and you can find out product details about that T table, okay, because of some massive connection to the network. Okay, here is the product information. You can order it, okay, because this one is designed by someone, some designers, and sold by some design products, shopping mall. You can order it and edit this design by using this real world based environment. Okay. This is a quick demonstration of homestyler.com. The reason for demonstration of this homestyler.com is, as one quick review, I like to show you something advanced, something newly developed way of design. Take a look at this corridor, this elevator hall picture taken by someone's smartphone, and auto generation of the wall edges and floor and ceiling. Simply assign the height and take a look at wall pattern. Wall pattern gonna be changed, redesigned by using simple touch-based interface, and some additional features, including this even wall frame pictures, can be added. So simply enhance your design capability for remodeling for existing space. Simply take the picture and try to update its decoration or colors, whatever, and generate cloud-based rendering by computers scattered around the world, not your CPUs. Also, you can load this kind of predefined one. Okay, just one approach of smart way of CAD, object-based CAD. Homestyler is not a simple CAD, but a simple BIM application, building information modeling tool. Okay, there is no polygon, no lines, no vertices, no push-pulls. Okay, so do you think which one is the smart way and which one is the design software fit to you, someone like you, for architecture major, interior architecture design major? Something like this, okay? Homestyler, not 3D Max or some other geometric-based things. But in reality, for faster and complicated 3D geometric visualization, surface-based modeling tool is still available. But in the future, designer's future, or probably your future, there are amount of this kind of building information modeling-based design tool gonna be available a lot, okay? Simply computer recognize this one is door, not rectangle shape with 2 holes. That's big difference. In AutoCAD, if you click this layer, this object, there is only geometric information, okay? Its length, position X, position Y, and some layer information, and label. Label name is door. And then human can recognize this one is door, or because of this geometric shape. But computer doesn't understand this is door. It doesn't matter. They are collection of lines and surfaces. In Revit, building information modeling tool, this is Revit, or even Homestyler can recognize this is door object. If you click this one, computer displays this is double panel door, which has its height, thickness, color, material, and which walls or room related to this one. which rooms, 2 rooms connected by this door, and so on. Amount of additional information you need as a designer, okay? The information we need is something like that. Which wall, which space connected, and the height of the door, and the door material, and so on. That kind of associated information is what we need to know. It's something about communication, digital communication in ASFM industry, architecture, engineering, construction industry. You have your own design idea because you are in charge of design specific building interior, building exterior, or building related product. So conventionally, we need to make some abstraction, something abstract, okay, from your idea. This idea is not visible to anybody in the world except you, okay? You have a specific idea that's supposed to be visualized in abstract way. So in convention, we invented this kind of simple hand drawing sketches. Take a look at this one. In 1893, there is the architect firm company and professional architects, designers draw this kind of standardized drawings. What kind of drawings? Floor plans, standardized axonometric, isometric, as well as some section, elevation, and so on to represent his own idea, okay? This is one way of abstract, conventional way of representation. But nowadays, we are using this kind of computer tools. How about AutoCAD or even SketchUp? One part of this abstract, okay? One part of visualization, only for visualization. But how about this kind of information modeling approach? This is a door object, door-related properties. Computer does know this is a door. Drawing and visualization, you can easily extract floor plan, section, elevation, and so on, because geometry data is one part of this information model. Geometric data is almost 100% of this model, okay? But to this model, especially BIM model, we can reuse a lot different ways for designers' main focus. Finally, eventually, we can keep focusing on design, not unnecessary things such as polygon, such as lines, and so on. Of course, you have to know what are they, but we can keep more focus on design and its development. So this is conventional design computing, conventional CAD. We have focused on geometric shapes. Let computers do what have drawn. Instead of hand drawing, we made letting computers drawing, okay? 50, 60 years ago, 50 years ago, 40 years ago, they are looking like 3D Max or AutoCAD, SketchUp. But new direction information modeling, especially building information modeling, focusing on information, let computers do what we have done, okay, entirely in terms of design life cycle, building life cycle, regarding construction and management and so on. So that is why we need to know something like this kind of advanced computing features. These two different representations simply compare the difference between geometric representation and building information representation. 2 points and 2 rectangle shapes. And then we can recognize, okay, this one looks like a room which has 4 walls. This is a symbol, okay? Computer doesn't understand that this is wall, this is space. It understands only there are 2 points and 2 rectangle shaped lines. That's it. So rectangle point and rectangle point relationship. in terms of topology and geometry. Okay, that's it. But within BIM system, computer understands 4 points and more points and 4 walls and 1 single space. And the relationship diagram much complicated. We can recognize wall 1 has connection to wall 4 and 2, not 3 directly, something like that. And then we can analyze this design. We can apply this one, something advanced one, and so on. That's big difference. Same visualization, but totally different, okay? The comparison between geometric drawing and building information model. So in this semester, we focused on this vertex point, edge line, face surface. This is polygon, okay? And the shell shape to make this kind of 3D object. And we modify this one like this way by using camera, light system, editable poly, FFD, and also today's lab exercise is gonna be dealing with some more geometric editing tools. So designing geometry centered, some parametrics, editing, update vertex, edge, polygon by using edit poly, that's your design. Something weird, something different approach to design. But in parametric modeling, in solid modeling, especially in building information modeling, we can focus on which is the part, which is your design. For example, this is simple definition of part, window frame. Based on window frame, we can assign 10 rows and another 10 rows, and then we can design our kind of freeform surface. This part gonna be auto-assembled like this way, parametrically, in automation. By using 3D Max, we have to use some editable poly and inset, but it's not editable. It's not recognizable to computers. But this one, auto-generated by computers. What you need to do is defining this one, part, and define your surface, your building exterior, interior, and so on. This is one of the advantages of when you are doing some parametric modelers, building information modelers, such as Revit, okay? Anyway, our focus was here, geometry-based approach to design, especially for design representation, design visualization, okay? That is the quick review for this semester's major focus, geometric modeling, okay? Let's have a break and then move on to the lab exercise.